Okay, good evening, everyone, once again. So, my name is Anupama Singh, as Sir have mentioned, and I'll be talking about sampling design and how we develop our sampling design in a way so that we can come to a proper inference or proper conclusion, or we can say in a way so that we can conduct our study properly. So before starting, I would like to request all of you to please feel free to ask any question in between, because if it is more of an interactive session, that will be more interesting, right? So sampling design, right? So all of you are either research scholars or faculty in different colleges or institutes. So now we are talking about sampling. Any in any kind of research, sampling plays a very important role. If especially if you are going to perform a primary survey or primary data based study, right? So there are different kind of data sources that are available online, and there are different kind of government website and non-governmental websites which provide various kind of data on which you can conduct your study. But a lot of time it happens that the topic that we want to study or we want to conduct research on, that does not have ample size of data or appropriate data available already. In that situation, what we do is we go for collecting the data, right? And to collect the data, there are different kind of problems that we face. And that problems starts with the question of how and why and when to collect data or to conduct sampling, right? So in a case where we cannot go for complete enumeration or where we do not have any secondary data available, we opt for sampling. And that is why today we are going to talk about sampling design and developing a good sampling plan. So first of all, what is sampling? So वैसे I know each one of you have would be familiar with the term also and the concept also. But when we talk about sample, we talk about a smaller unit of something very big, right? So in our statistical terms, we consider a bigger population or some set of observations that is very large in number and where the complete enumeration cannot be done or need not be done, right? So in that case, what we do is we draw a representative part of that particular population and we call that a sample. So the bigger set of individual is called as population, and it is also called as a universe in some books, but in a standard notation we call it as a population. This population can be different for different people and different research or different study objectives, right? For example, if you want to, let's take a very basic simple example. So if you want to study the average height of a group of individual in some particular population, well, let's say Uttar Pradesh, right? So what I'll do is the population here, the bigger set of observations or bigger set of individual will be the whole entire population of Uttar Pradesh. And the certain age group can be my smaller size, smaller group, right? So since we are focusing on one age group, that particular age group and number of individuals in that particular age group will be our population. In this, population is different, and then we will draw a sample. How we draw a sample and the characteristics of samples, that are a different thing. In other way, if we want to study, for example, the number of cancer patient or the recovery of cancer patient in different stages of cancer, then our population will become different, right? Then our population will be the number of individuals who are suffering from cancer at that particular time. And then obviously if the number is very large, we do not want to go to enumerate the whole population. And certain times it happens that we are short on funds and etc. other things, or we cannot approach each and every individual, or we cannot go to every nook and corner of the particular geographical area. So in that case, we opt for sample. So a smaller part of a population is a sample. Sampling, when we talk about sampling, we usually say that sampling exists in every single day of our life. I'm sorry. Sorry, I had a, just a second, please. So can I be excused for a minute? Hello?
Sure, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, sorry, I am getting a call. I'll just be back in 2 minutes.
Hmm.
Hello? Hello, is anyone there?
Yes, ma'am.
Yeah, I'm extremely sorry for that.
Stop.
Okay. Actually, sir, I left the office early because I had to take the lecture from the home. So that is why I was getting a call from the office. Okay. So where were we? We were talking about the smaller portion of the population that is called as sample. So when we defined sample, we defined the whole process of sampling to be learning about a population on the basis of a representative part. That representative part should be such way that it should represent each and every individual of the population. So when we were talking about the example of height of individuals, so the sample, the adequate sample will be in such a way that it includes the individual from various age groups, or each and every age group that we are taking, and various caste include, and various geographical part of that particular population, right? And the whole objective of the this process is to conclude about a population based on a shorter form of study, which is your sampling. So we are not going to test, or we are not going to examine the whole population. But we are going to study a very limited part of it, and we are going to draw important inferences or conclusion based on that particular study. So the whole process of sampling includes different kinds of steps. That includes selecting of a sample, making questionnaire, collecting information, making inference about the population. So we are going to focus on two aspects here: selecting the sample, how do we select a sample or how do we make a sample, and then making questionnaire, because it is also a very important part of it. And then we collect data and we go for analysis later on. So first of all, we are going to talk about sampling frame. So before we go for sampling, we define how do we go to frame a sample or to make a sample. First of all, we have to be clear about our objective. First of all, the problem is that we should be definite about our statement of the problem. So when we were talking about study of the recovery of cancer patient, then we are very particular about our objective, that we are supposed to study, or we are supposed to understand the status of the people who are suffering from cancer in particular geographical area, right? In social sciences, there are a lot of concepts like understanding the level of education or various kinds of factors that affect some other factor in one way or another. So in that case, we try to understand what would be different kind of factors. For example, if there is less education in some particular class of society, and we want to understand what are the factors behind the lack of literacy or lack of education in that particular society. So we all know that the factors that affect education can be uh, standard of living, right? Low income groups possibility, and there might be caste or religion based problems that should be there in the area, or if it is a rural area, that there will be chances that there would be less education. So here we know what kind of factors we have to study. So our objective is clear, and we understand that what we have to study for understanding that particular phenomena in the population, right? Based on that, we will make a sampling frame. A sampling frame is a very simple thing. A sampling frame is a listing of the whole population or individual in the population from which we are going to acquire a sample, right? So it can be anything. It can be a map, or it can be a listing, or it can be any material that can provide us a way or a path to understand the population. So in different kind of geographical areas, we make the list of blocks, or in rural areas, we make the list of villages, and then we have gram panchayats, right? That in that way we can make the list of the whole household size. So it is some kind of information that is required to draw a sample, right? And it should be prepared in advance. Then we have to determine the structure of sample surveys. Structure of sample surveys is how we are going to conduct, or how we are going to execute our sample, right? So first of all, if you are doing a listing of the household, you will have to be very particular about the time and the date when you are going to conduct your sampling survey, right? So these kind of things should be fixed in earlier part of the study, so that the whole process of sampling becomes easier, right? Then we have sampling units. So sampling in units is nothing. Sampling units is um, every study has different kind of objects, right? So if you are going to study the cancer patients, or you're going to study the education, or you're going to study the height or weight or BMI of a certain population, then the units here changes, right? So if you want to study the recovery of cancer patient, your sampling unit on which you are taking the measurement will be the individual, right? So unit is nothing but the particular object on which you are taking the measurement. So there are usually two kinds of unit. No, sometimes when you do is when you are studying about the height, you say height in meters. That is also one measurement and that is also a unit. But when you are talking about sampling, then sampling unit becomes the object or the individual on which you are taking the observations. It can be different. In marketing, we have different kind of things. We have different kind of studies in which the sampling unit can be different, right? It can be the consumption of any particular product, right? Or it can be the income in different groups. So that becomes your sampling unit, right? So, but the whole thing is the important aspect is that you should understand what your particular sampling unit is. Because if you understand it, then you will be able to take the measurement accurately. The sampling unit should cover entire population in the sense it should be population representative. It should be distinct, unambiguous. Unambiguity is very important. It should be very clear that what kind of unit you are taking. Just as I spoke that the units can be different. It can be different in the way that you're taking the measurements of the height or you're taking the impact of some kind of medicine, right? So it should be clear and it should not be ambiguous in the sense because when you are going to conduct the sample survey, you are going to take responses from different individuals and they should understand what your sampling unit is. Obviously, the term unit will be clear to you, but your sampling unit, if it is clear, then you will be able to gather the information from the right person. For example, if you want to take the information on income, so you're not going to ask a child in a household, right? What you're going to do in that case is you will go to the household, you will talk to the head of the household, right? And then you will ask the monthly income or annual income of the family. So in that way, it is clear that the head of the household is your sampling unit. Sometimes it happens that you take one household as one unit, and sometimes it becomes multiple units in one household. For example, if you want to take the income, so income is a household property, right? So in that case, what you're doing is you're going to one household and you're asking about the monthly income. So that household will only give you one observation, right? Now, if in the same household you want to study the education, so there might be 4 children in the household or there might be 3 children or 2 children, right? In that case, your sampling unit will change. Your sampling unit will be 3 in one household. For each kid or each child in a household, there will be one sampling unit. So that is how the sampling unit changes. And if it changes, then the size of the sample also changes, because if you have to collect the information from each and every household as one unit, then the coverage of the household will be big, right? And if you can take 3 sampling units from one household, then you'll have to cover lesser number of household. It should be non-overlapping in the sense it should be independent also. All the units should be independent with each other. Now, obviously, when we are talking about sampling, first we are going to talk about the errors that can occur in sampling. So there are different kind of sampling errors and non-sampling errors. When we talk about errors, we are familiar with the concept of errors as chance errors and assignable errors, right? So in this case also, we have different kind of errors that are random in nature or that occur by chance, that are not under our control, and there are errors which are and which can be controlled by human being or by processing or analyzing the data differently, right? So from the process of when we start doing sampling, so from the process of making our sampling frame to the end of the process, that is the collection of the data, different kind of errors can occur in the sampling. There are different kind of sampling errors. One is sampling error and another one is non-sampling errors, right? So sampling errors are the errors that occur in the process of drawing samples. Process of when you are framing the sampling, when you are when we are framing the sample and till the whole methodology of the sample is done, right? So if the error occur on the part of the researcher, then it is sampling error. And then there are non-sampling errors that can happen when you're going for invigilations, right? In that case, if the person is responding in a wrong way, then it can be a non-sampling error. Or if the person is not there, then it can be a non-sampling error. So sampling errors, right, again, errors involved in drawing inference about the population on the basis of sample. So in this, we are talking about the process of sampling. Because of, it can also happen because of selecting a sample which is not the representative of the population, because when we are saying, when we are talking about sampling, the sample should be a good representative of the population. If we are focused on only one part of the population, then it is very clear that it will not contain the whole variation or dispersion that is in the population, right? So when we are collecting the data from only one focused group of the population, then it will obviously not be a good representative of the population. Then obviously our results will differ because the observation that we are taking is wrong. Sampling error usually decreases with the increase in sample size, non-existent in census. So we all know the census is the complete enumeration process. So when we are talking about census, it is clear that we are taking information from each and every individual from of a geographical area. So in that case, obviously the sampling errors does not exist. Sampling, when there is the sample size is big. So it is the property of any phenomena that when you take the larger number of observations, then it is the variation in the whole set of observations decreases, right? So in that way, the sampling errors, various kind of errors, they decrease if you increase your sample size. Because what will happen is you will have different kind of variety of observations on your single variable, right? In that way, if the sample size is continuously increasing, you will get het different heterogeneous data in your one sample, and the average will come out to be the exact value or a representative value of the population. So it is always good if we go for a bigger sample size, but at the same time we have the restriction of time and cost that restricts us to take a bigger sample. So we try to find out a sample that is more representative and smaller in size, so that we can do our research cost effectively and time effectively. There are different kind of reasons for which sampling errors can occur. One is faulty selection of the sample. That earlier we were talking about being representative of the sample. If the sample is not representative, obviously it is but natural to happen that an error will occur. Or even if we are not able to rectify the error, or we are not able to understand that where the error is happening, the result that will come out from that study will not be uh, important, right? So for example, again, if we want to study your cancer patients again, right? I'm taking a very menial examples that are easy to understand to everyone. So if you want to study some kind of influence or some kind of morbidity that is happening in a particular geographical area or individuals, so any kind of disease that is prevailing, and we want to study that particular disease. Now, what happens is, if we want to study that particular disease, then our population at risk will be our representative population, right? For example, if certain kind of disease happens only in the kids or children, and we are taking the whole sample, whole population of the adult age groups also. So we are taking the unnecessary elements in our sample, right? And our important sample or important people, individuals are leaving out, because in that way we are going to miss the units that are important for our sample, right? So what I'm trying to say is, if we want to study a particular factor or particular phenomena, then a sample should be such that the population at risk should be considered, not the entire population, right? In that way, the population at risk will give us a better representative sample for our study. Faulty work during collection. That is one kind of error that happens that comes under sampling errors as well as in non-sampling errors, both, right? Because what happens is, the whole collection of the data comes under the sampling process only. So if we are going to conduct a sampling survey, and our interviewer is not conducting the sample in the manner that he or she should, then the observations or the values or inputs coming from the respondents will be wrong. So in that way, another sampling error will be done. For example, a lot of time it happens that our interviewers are not that much willing to work, right? So what happens is, they go to a place and they visit certain number of households, and then they think that they understand that all the households in that particular neighborhood will have the same kind of characteristics. And a lot of time that also happens, that you have to collect or fill a number of questionnaire in one day, right? So what happens is, they are not able to collect the whole, complete the whole questionnaire. So what they do is, based on those particular information that they have already gathered, they fill up the rest of the questionnaire on that particular information that they already have. What happens is, if there is some kind of variability that is, or some kind of important information that is in the households which are not being interrogated yet, that information is lapsed. So that is something that could have been controlled, right? But it is a part of sampling error, because it comes under content, because we are not covering the whole content of sampling units, right? Then we have method of analysis. Method of analysis comes on later, but the method of analysis, it should be method of sampling procedure actually. The different kind of sampling designs that you are using. If you are using a wrong sampling design for some population, then it will give you a different kind of sampling error, because we have different kind of sampling plans and sampling designs that are available in our theory, but every situation has different aspect in which you can apply different kind of sampling plans, right? Then there are non-sampling errors. So non-sampling errors go out of the sampling errors. A major kind of non-sampling errors are non-response, or the content error, coverage error, right? So in that case, after the questionnaire is being prepared, or after the whole sampling procedure is done, when the sampling survey is actually being conducted, non-sampling errors occur at that time. Now, non-sampling errors is something that occurs in both complete enumeration, that are censuses, and sampling. So it can happen everywhere. Now, because non-sampling errors uh, are more serious, because uh, it happens because of the interviewer, right? So what happens is, if some individual is giving you wrong information, or some interviewer is taking the wrong information, so in both the cases you are getting the wrong information. But it is one kind of error that can be rectified. If it is not rectified on time, then it will continue happening, right? And if it continues on happening, then your whole sample will get contaminated by that particular sampling error, right? So if one individual is not entering the value in the correct manner, for example, if he or she is collecting the data on income, and we have different classes of income in the questionnaire, in which he has to put some kind of value, right? And if the interviewer does not understand it, or maybe doing it on purpose, if if uh, he or she is not putting the value in the correct option, then it shows that he will continue the same error again and again, right? So for the whole entire sample, the error will continue to happen. And now what happens is, your whole study goes to a waste, right? So it is very important, because these kind of errors can be rectified if one wants to. So it can happen at every stage. It can happen during the planning or during the execution of that particular sampling survey. There are different kind of reasons, as we were talking about non sampling errors. Obviously, non-sampling errors also happen for the reasons. I was talking about non-response. There are response errors also. In one case, there can be incorrect understanding. Incorrect understanding can happen on both the parts, both sides of the table, right? Either the interviewer does not know how to ask a question or how to fill a questionnaire. That is due to the lack of the training or understanding of a subject. And on the other part, the respondent does not understand the content or understand the questionnaire. Sometimes it happens that when we go out of a particular geographical area, and there are different kind of barriers that we face, right? So if we go into a rural area, then we have language issues, and then we have to make people understand why you are conducting the sampling survey. You have to convince them that they should give the proper information or the correct information, right? So if you are able to make them understand, they probably will give you the correct information. But lot of time it happens that the respondents themselves do not give the correct information. So even if you are doing your best, the response is not coming to be as good as it should be. Then there is prestige bias. Prestige bias is something, uh, for example, again, if you are going to a household and you want to know the level of education in that particular household, right? And the individual, the respondent, will not give you a correct information. Why? Because they would think that if we give the correct information and that is something which is not up to the mark, then it will be shameful, right? When we are talking about prestige bias, it also happens in different kind of diseases. When we go for different surveys, what happens is, if we want to ask it, do you have HIV, right? A lot of people will not tell you, because they will be thinking of that it will be shameful for them if they accept it. A lot of thing happens if they're suffering from mental illness or something, and obviously in that case they have to be dealt differently. To avoid these kind of biases, we have different kind of sampling methodologies which we can apply so that we can reduce these kind of bias. Self-interest. Self-interest is again, it has happened or it happens a lot also. When we are going for income, sometimes the people in urban areas, they do not give the correct information about their income, right? Because they think that if they're earning more and they're not filling the income taxes or properly, then if they mention their correct income, that will be harmful for them. Bias due to interviewer, as we were talking earlier, if the interviewer is not that much educated to take the information from the population, or if he or she is lazy enough that they do not want to take the whole information and they do not want to go to each and every unit of the sample, then these kind of error may occur. Respondents' inability to understand, it is very, very important that each and every respondent should understand the importance of the study that you are conducting. Then there are non-response error. Non-response error, they occur, but in that case, we have a solution that we go to the unit again and again. So non-response errors are those kind of errors also when the individual refuses to give you any kind of information, right? That is also a non-response error. Then we have um, uh, usually if a particular interviewer is going to the household and the person is not here, right? In that case, what the interviewer will do to save time and money, the interviewer will skip that particular household and they will go to the next household, right? So that particular household that was supposed to be in the sampling frame, that that omits, right? So that kind of error is also considered as non-response. So any kind of error that happens because of non-response from the side of respondents are considered as non-response errors. Then there are compiling error. Compiling error usually happen after the collection of the data. So as much as it is important that we collect the data in a proper manner, it is also important that the whole data that is being collected or being collected should be input in a proper way and should be displayed in a proper way. So if you are making the tables or giving the raw data, or if there is in the entry process or the coding process, it should be done very carefully so that these kind of error does not happen. Then there are publication errors, but those errors come very later on. The more important errors lie in the data processing. Properties of a good sample. This we have talked about. वैसे. The sample should be representative in a way that it should contain one individual from each and every section of your population. If you are taking any kind of data that includes the caste or religion as a factor that can make an influence, then a good sample will be a sample that includes each individual, or not each individual, at least one individual from each caste or religion, right? If you are taking some age group in which you want to study some factor, then individuals should be there from each age section in which you are going to study the particular phenomena, right? So if the sample is representative, then the study will give you better result. Adequacy. Adequacy is basically the size of the population, like how much the number of individuals are enough. That is adequacy. So a sample should be adequate enough. How to make it adequate? We go through different type of sampling procedures and the sample size determination. All the items in the sample should be independent of each other. Independent in the sense one individual unit should not affect the response of the another individual unit. That usually happens when we are taking information or we are gathering information from different units in one household. That happens. So for example, if you are taking some kind of phenomena that is very sensitive in nature, right? So if you are collecting a sample based on domestic violence, now what happens is domestic violence is some phenomena in which one unit can affect another unit, right? So if you're going to a household, the particular spouse will respond differently, the victim is going to respond differently, or the people or the relative will respond differently, right? So in one household only, you are getting different kind of responses that cannot be true. In that particular situation, your sampling should be in such a way that, or conduct of the sampling, the interviewer should take the unit, that is the victim in that case, separately and confidentially should take the information from them. Same thing happens when we are talking about mental illness, or and even it happens when we are talking about some topics like dowry, right? It is one phenomena that still exists in our society, but we do not accept it, right? So in one household, people may have different type of perceptions, right? Now we have homogeneity in the nature of the units. Homogeneity का यहाँ पे मतलब है that all the units should be from some set of groups, right? If you are taking different caste or religion, then there should be a section from one caste, there should be a section from another caste, there should be a section from another caste, right? So there is heterogeneity and homogeneity available at the same time. Now we come to our major topic of discussion, that is how should we develop a sampling plan so that we are able to uh, give better results or better outputs. So first our issue is actually it's a, so in some places you will see it is a 5-step process, in some places you will see it's a 7-step process, but it is more important that what kind of steps that you are studying, right? So first of all, it is very important that you are clear about your objective and you are defining your problems correctly. So if you want to conduct some kind of study, then you should be very clear about what kind of sampling units you are taking, how much of area or geographical area has to be covered, what your target population will be, how you are going to classify your population, right? So it should be very clear in your problem itself. Like a lot of times when we are conducting any kind of research, so what happens is in our research only we mention a case study of so and so place, right? So in that title itself we are mentioning that our research is being conducted on some particular population, not the whole population, right? It can be some tribe, it can be some different state, it can be district or inter-district, right? But it should be clear. Identifying and specifying sampling frame. Again, the sampling frame includes the list of all the individuals that are being included in your study. It can be one household for one observation, or it can be multiple observations in single household. But for both, the listing should be done, or there should be any kind of mapping or any kind of guidelines or guide that can show you how you are going to frame your sample in your given geographical area or your population under study. Then comes the most important aspect, that is choosing the sampling design. Now, a lot of people come with this problem because most of the study that we see are multi-stage sampling you would have studied, right? So in multi-stage sampling also, but we are not clear about what kind of sampling we are using at each and every stage, right? So it is very important that we understand that what sampling procedure or methodology you're going to use in your sampling. Then we have determination of the sample size. Obviously, You cannot take the sample size of 1000. That is not necessary because it might not be in your ability to get the whole sample of 1000, right? Uh, a single person cannot collect the information on 1000 individuals. At the same time, we might have the problems in the funds. So for both the purposes, cost and time are getting compromised. So in that case, the sampling size should be small. Again, if you are taking the sample size as to be 30 or say 20, then it will be too small to draw any kind of conclusion, right? Because if you are trying to infer something about a bigger population, then it should be big. So how big it should be, that can also be done or calculated in advance. And that is done under the determination of sampling size. Then is formation of questionnaire. Formation of questionnaire is very important because you need to understand that what kind of questions you are going to ask your particular target population, and are the questions, number of questions good enough, or if they are too much or too less, it should not be there, right? And then we have collection of data. After we do all this exercise of defining a problem and sampling frame and sampling designing, we go for collection of data, and that should also be done very carefully, because if some kind of error occurs, then again it gives you um, it costs you money and time at the same time. Choosing a sampling design. We have a lot of sampling designs, sampling procedures that are available. These are some of the sampling designs that we are going to talk about. Obviously, in non-probability sampling, as we are doing researches and various sampling methodologies, there are different kind of samplings that are still being discovered or innovated, right? So, but we are going to talk about these more because these are most of the sampling is done on basis of these particular sampling procedures. So we have two kinds of sampling designs. One are probability sampling and another one is non-probability sampling. So as the word cleared says out that probability sampling has something to do with the probability. And there you have the probability, or we call it in a simpler terms, chance. The chance of being selected in a sample. So how we are giving chances to different individual units to be included in our sample. And the non-probability sampling is something that is again very much used in qualitative analysis. It is very much used, right? So non-probability sampling is the sampling procedure where probability does not play any kind of role in the selection of the sample. In non-probability sampling, most of the decisions are taken by the researcher on the basis of the prior or the current knowledge about the phenomena. And a lot of time it happens that you don't have that much of technically sound background. Technically sound background means you don't have all the parameters, all the values of the population, right? So if you want to study the average height of a population, now what happens is average height, we are talking about average height here. So we should have some kind of idea, right? So in probability sampling, what we can do is uh, we can make certain kind of rules on the basis of which each and every individual can be included in your sample, right? But at the same time, if we are going to study some kind of, say, preference of uh, brands in buying a phone, right? So in that way, it is not important or it is not necessary that you have all the information that you require. You don't have the uh, different ages might have different kind of preference on the brands, right? Maybe the adults don't prefer that much, or they have different reasons for selecting different brands, but you don't have that much. information. So in that case, what a researcher is doing, like we are using our prior information or prior knowledge about that particular phenomena. For example, we know that this much of brands are available in the market, and this much sales of this particular brand is there, and youngsters, for example, might prefer Apple but they don't have money, and old people, they don't prefer Apple but they have money, right? Ease of access and availability. Some people prefer Android, some different kind of Windows and all that. So these kind of information, if the researcher has, then they can go for sampling. They don't need to go for probability sampling because the preference is something which is qualitative. There are different kind of rating and scales also on which basis you can go for sampling. So in probability sampling, we are going to discuss simple random sampling, stratified random sampling, systematic sampling, cluster sampling, and multi-stage sampling. I'm sure you would have heard the names of all of these samplings earlier. And non-probability samplings, we are going to discuss about purposive sampling, convenience sampling, snowball sampling, quota sampling. That is all based on some kind of rule, but that rule is being made by the researcher themselves and not some kind of theoretical procedure already available. Firstly, we are going to discuss about random sampling. So random sampling, as we say, the units are distributed randomly, right? We are not going to put it into some kind of complicated method. So if you have the list of the population and we are going to choose any unit, we just close our eyes and we are choosing the unit, then it is random, right? You are not going to prefer, for example, if I'm standing in a class of 10 individuals and for example, all the girls are standing on one side and all the boys are standing on one side, right? So in my left side there are girls and then in my right side there are boys, and I'm standing in the middle and I have to choose 5 people from those class or 6 people, for instance, from that particular class. Now a random sampling would be something in which each and every individual has equal chance to be selected by me, right? So if I'm only focusing to the right side, then the left side is being completely ignored. Or if I'm standing in the right side, then the people who are in my right side are getting more chances of being selected, right? So that will not be random. The random thing will be that if I'm moving to all the individuals and I can put hand on any individual, whether it is a girl or boy of particular age or not, or particular height or not, right? So when we talk about random sampling, the probability or the chance of getting included in the sample should be equal. We have two kinds of sampling in that, SRSWR, that is simple random sampling with replacement, and we have simple random sampling without replacement. In with replacement, what we do is we put the, for example, we are gathering information from 10 individuals. I took the, I take one individual and I take information from that particular individual and I put them back into that herd, right, of a particular group, and then I choose again, right? So a person can get selected more than once, but the sample size is not getting changed, right? So if the number of people in the group was 10 and I was taking the information from for say 6 people, right? So the whole population that was 10 will be fixed. I'll take information from one individual, I'll take the sample and one unit is being taken, then it will be getting replaced again. मतलब it won't be getting replaced, वो वापस वहीं पे जाके उसमें group में जा रही है, and the same information can be taken from the same individual again. Okay, and without replacement means if you are taking that individual out and you're gathering the information and you take that individual out of that particular group. So if we had the population of size say 10, then it reduces to 9. Right now, the person who was being interviewed is out. So now all other people will have equal chances of getting selected except that particular individual. There are different kind of processes in which you can do the random sampling. One is very famous lottery method. We make the list and we'll put it into some kind of bowl or something, and we take one ball out in which the number of that particular individual is, and then that particular individual will be giving you information. That kind of thing was done during Second World War, or at that time they had different kind of date of births, and the date of birth only, that was uh, the whole date of births were uh, uh, put on chits, and that was put in a bowl. And for example, if I say 6th of August, then all the individuals who were born on 6th of August will have to go to the war to fight, right? So that is a simple lottery method, because the whole process is now randomized. Then we have random number table. Random number table is some statistical table that is already available. And in that we have different kind of method in which you can select the units. Then we have software. Nowadays you can use different kind of software, or even if you are using Excel. So Excel gives you an option of generating random numbers from one range to another, right? So what you can do is, if you have 100 total population of 100 units, 100 individuals, and say you want to um, take the sample of 20 individuals, right? So you can write random number, and from 1 to 100, 20 आपको number चाहिए. So you put 20 numbers and one from 1 to 100 range. So it will give you 20 digits, right? Uh, so you can pick that particular number of individual from the list, and you can take the information. But it is important that you assign a list at first, right? There are certain limitation, obviously, because uh, we have a simpler method. No, a method is very simple and it is not complicated at all. There are no restrictions. So obviously there are some kind of limit. कहीं ना कहीं तो limitation उसमें आ ही जाएगा. Random sampling, what happens is, when the population is very large, then simple random sampling becomes very tedious, because you cannot have the list of all the individuals. For example, if you may have list of one section or two sections in the geographical area, it is not always possible that all of the list is available. Even if you are selecting from a random number table or something, maybe the number that gets selected are from certain class. That is possible, right? So that kind of error happens. And the problem occurs when the whole population is very, very heterogeneous in nature. Heterogeneous matlab all the elements have different kind of nature, or at least some elements have different kind of nature. Okay, some section has different. So it might happen that all the sample comes from one section only, or two sections only, or one section is getting excluded, right? So it happens. In that way, simple random sampling might not be very appropriate. Then we have probability proportional to size. Now, in simple random sampling, with or without replacement, the probability of getting selected at any selection was equal. Now it happens that the probability might not be equal. One of the most popular method is probability proportional to size. So what happens is, for example, you want to, I'm sure that everyone would have heard about National Family Health Survey, right? So in that, what happens is, they take medical information about each and every different populations of India, right? So it happens in every state and every district. So what happens is, um, for example, we are taking the information from Uttar Pradesh. And at the same time, Uttar Pradesh is like the biggest population in the whole country, right? And at the same time, you're taking population from, say, Andaman and Nicobar or Daman and Diu. That is a very small geographical area, right? So what happens is in Uttar Pradesh, even 1 lakh of the sample size might not be enough. And in Daman and Diu, maybe 10,000 is also good enough. But if we are not doing it in that manner, if we are taking 10,000 from each and every geographical area, then that particular sample from that geographical area may not be representative or may not be good enough in number. So what we do is we do the probability proportional to size sampling, right? In that case, what we do is the probability of getting selected is proportional to the size. That means that if the geographical area is big or the number of individuals in that particular geographical area are more, then we'll take bigger proportion or bigger size of sample from that population. So for say एक अगर population है and the population size is say 10,000, right? Then we say that will take 0.4 or 0.3 proportion, 0.3% of that population, right? So 0.3 population, 0.3% of the population from 10,000, right? Now the 0.3 population from 1,000 will be different. So in that way, we are going from to the size, to the sampling size that is proportional to your geographical area or geographical population. Okay, I hope it is clear to everyone how we are going from probability, right? We are not going to consider the different kind of population as same. We are going to consider different population as different units who can be that can be big or small. So in that way, we will make our sample in such a way that we get the sample which is representative of that particular population. So if the population is big, we take a bigger sample, and if the population is small, obviously we take the smaller sample. Then we have stratified random sampling, again a very popular sampling method. So in that case, what we do is we divide the whole population into different kind of strata. So for this, I'll use an example, a case study. Uh, for example, if you want to study the status of mental health, right, in the adolescents or in the age group of say 14 to 19, right? So that is the age group where a lot of changes occur and all that. So if you want to study the mental health of 14 to 19 age group, and you have a geographical area, say um, say it is Uttar Pradesh only, I know that better. So being a big country, or sorry, big state, what happens is it has uh, different sections of geographical areas that possess different kind of property, right? Or let's take some better example. For example, yeah, let's see if we want to study the mental health only in the age group of 14 to 19 adolescents, right? So what will happen is we know that rural area will have different kind of responses, and urban areas will have different kind of responses. And it might be possible that there are semi-urban areas also, right? So what we can do is we can make or we can bifurcate our population into different classes. And those classes we called as strata. The stratas are those part of the population which are homogeneous in nature. Homogeneous in nature means all the individuals or all the units, all the items that we are talking about have the similar kind of characteristics, right? So we divided our whole population into rural, urban, and semi-urban. So we divided the population into three strata. Now, the rural population will have the characteristic of being in rural, depending on the agriculture, right? And the urban areas will be different. Semi-urban areas obviously will be different, right? So we meet three strata in that particular situation. Now we can go further in a different way. जिस तरह से हम लोग sample कर रहे थे, उसमें हम आगे बढ़ सकते हैं. We can use simple random sampling, or we can use a probability proportional to size sampling, right? But first we did your stratified sampling. Major issues. So the issues that occur in this is the basis of stratification. When a researcher is dividing their population into strata, that the knowledge of that particular researcher about the phenomena should be clear. When we were taking the mental health, we were talking about the mental health of the adolescents. The researcher here knows that there might be different kind of responses from rural and from urban area, right? Because there might be possibility that there are more joint families in rural areas and nuclear families in urban areas. And we can say that might affect your mental health, right? So in that ways, the researcher knows. But if the researcher didn't know, then maybe the strata, the basis of his of making the strata would have been different, right? हो सकता है वो एक ही particular population में से दो तीन factor बना देता, right? So अगर if that would have happened, then probably the results would have been different. So we make our strata in such a way that they have similar characteristics, right? They should be homogeneous within and heterogeneous outside. Now in the rural and urban area, both the strata are very much heterogeneous between. There are a lot of variation in between. But as one strata, they are homogeneous in themselves. Okay, all the units from that particular sample. Number of strata, how many number of strata should be there? Obviously, when we are talking about the stratified sampling, not too many strata should be there, right? Because in that way, we will lose the whole idea of stratified sampling, right? Idea of stratified sampling means making the homogeneous strata and which should be heterogeneous between, right? Okay. Then we have systematic sampling. So systematic sampling, some lot of time it happens that we have a very big population, and the whole population cannot follow one particular kind of uh, methodology, right? And we don't want to go for the whole probability sampling at the first only, right? So what we do is in that way, but we want to follow the scientific method also. It should be scientific, it should be technical, right? What we do is we select one unit and random, and then we define that what the next unit should be, right? So what we do is, for example, if we have again, we have the individual 20 individuals in one class, and there are different genders in that particular group of 20 individuals. And now we want to take height. So why, if a person do not want to start with one first member, right? But at the same time, you do not want to follow the simple random technique, randomization technique either. What you can do is, we'll choose first unit at random, right? We might land on the fifth individual. Okay. And then we decide that we will take the next unit at some kind of interval, and then repeat the process of interval, not the randomization. So for example, we have the interval of 10th individual, right? Or let's make it smaller, third individual. So what we'll do is, the first unit, that was the fifth individual. We took it randomly, we took fifth individual. Now, what will be the next person that we will be choosing? Sixth, seventh, eighth, right? Third individual. Then after eighth, what will be? Ninth, 10th, 11th, right? Then after 11th, it will be 12th, 13th, 14th. Okay, so in that way, we are selecting the units. For example, we have to take 10 units out of the 20 individual. So we'll keep repeating the same spacing and same intervals until we get 10 people. So that is one way of conducting sampling, right? But the list should be there. It is not very effective when the population contains some kind of periodic variation, right? If periodic variation means, if we when we are talking about periodic fluctuation, so in that way, if you are taking information on some kind of time interval, time interval we are taking an example because it will be easier. So for example, you are taking the observation on one day on which the medication is given, and maybe then we are taking the next observation on, say, 7th day to see the effect of that particular medicine, right? And then we are going to the 7th day again to see the effect of the medication, and then 7th. So what you are doing is you are missing uh, the days that are in between, right? And now it might be possible that there were some kind of effects or side effects of that particular medicine during those first 7 days. So in that case, the sampling interval that we are taking is ignoring the possible fluctuations that are occurring to our sampling unit, right? And those observations are also important. In that way, systematic sampling might not prove to be a better way of handling things, right? In that way, we will have to study, make the intervals very small, right? For example, if you are taking the observations on second day or alternate days, right? So it should be very much uh, be accurate how you take the intervals. And if you are going for that, then it is better that we do not take the intervals, we take the different kind of sampling strategy. Then we have cluster sampling. Cluster sampling is actually the opposite of stratified sampling. That is the best way to remember it. Sometimes what we want is, we don't want the units, or we don't want the strata that are homogeneous in themselves. We want the data that is heterogeneous. So for example, in agriculture we study the fertility gradient of different kind of one field, right? So we divide field into different kind of sections. So if we want to take the uh, sample from one field, we would want that that particular area contains all the heterogeneity, right? So in that we do not want the homogeneity, because we know that the land might be fertile at one place and might not be fertile at the another place. Okay. So in that case, what would do is, we make the clusters in such a way that they contain most of the heterogeneity within themselves. But at the same time, they are homogeneous between themselves. So if you are dividing a bigger field into smaller field, all the smaller fields should be on an average be similar to one another. For example, you are taking the fields who all the fields of the farmers that all grow sugarcane, or they all grow wheat, or they all grow rice, right? So they are homogeneous. Externally, they are homogeneous, right? But we divide the whole field into different clusters, and they can have a different fertility gradient or different fertility in those different sections or different clusters. Okay, so in that way, cluster sampling can be more effective instead of stratified sampling. Cluster sampling has different kind of applications in agriculture area or the places where we need more heterogeneous groups. Okay, so that we can gather maximum of the variability in one cluster. This is also called as area sampling because again, because I was taking the example of agriculture, no? So it is the example of geographical area only. If we are taking samples from different geographical areas such as populations, so different states will have different kind of heterogeneity, right? But we bifurcate it in such a way that our clusters are heterogeneous nature, and your between the cluster heterogeneity is minimum. Okay. Then we have multi-stage sampling. So when we were talking about stratified sampling and PPS sampling, I was saying that it is very popular. Multi-stage sampling is actually most used method of sampling, because in this we have different kind of stages. So normally what happens is the population that we are enumerating or we are studying is very large and very diverse in nature. A lot of time it happens. Okay. So when we have that kind of population, any one particular technique might not be good enough for collecting the data. So we use multi-stage sampling. We make different kind of stages in the sampling procedures. And in the different kind of stages, we can apply different sampling techniques. Okay. But the whole methods, all the methods should have their assumptions fulfilled. Okay. So it is one of the kind of cluster sampling only, because we make clusters at first, and clusters should be heterogeneous within and homogeneous outside. Okay. And then we make the different kind of samples. So there is one example on the screen on the presentation. We make the clusters. So what happens was it can be clusters and it can be stratas also, but we make groups. So when we were talking about uh, mental health, we can also talk about the social status, right? Or the standard of living in the particular geographical area. So what we can do is we can divide the whole population in different clusters or different stratas, right? So what we can do is we can make the section in we can divide the section in rural, urban, tribal, semi-urban, right? These kind of stratas can be made. And then what we do is determining the number of sample units to be interviewed based on the PPS sampling. So what we are doing is we divide the whole state, geographical state, okay? We are dividing the whole state into we have different districts which can be different from the various aspects. So we took the geographical aspect as one: rural area, urban area, semi-urban and tribal. Okay. Then what we did was we have the district in those particular listing. We have the list of district, villages and households, right? So we will we will choose those particular villages, right? Which are in your rural areas, right? Or we will choose those particular blocks which are in urban areas, and we will choose some households from semi-urban, matlab blocks or villages. When we talk about rural area, we talk about villages, right? And when we talk about urban areas, we talk about blocks. Okay. And when we are talking about tribal areas, again, there are villages, right? So what we did was we have four strata, and these four strata have different population. So we have total rural population, total urban population, semi-urban, and in that way. So whichever population will be big, we will take the bigger sample from that population. Okay. And then we will follow the same method for selection of villages and then for selection of household. So the total sample size will be bigger for the bigger population. If your urban population is big, we'll take the bigger population from that. So the whole idea is that PPS sampling is playing a more important role, but we are forming clusters based on different phenomena or different characteristic of the population. So in this way, we are dividing our sampling into different stages and we are collecting the data. And in most of the research projects that we conduct in the social sciences and most of the researches in various social sciences and commercial background, we get this kind of problem where one particular sampling method is not applicable. And we have to divide the population or we have to do the sampling in different stages. And in that situation, multi-stage sampling is a very good sampling technique to be used because it gives you the flexibility of moving around. But it is all statistical approach at the same time. Then we have non-random sampling. Now, non-random samplings are good, easy. But obviously, it depends on the judgment call of the researcher. That is very important. So first is convenience sampling that we are going to talk about. So convenience sampling, accidental sampling भी कहते हैं, non-representative भी कहते हैं, useful only in exploratory research design. It is not, we are being judgmental here. Convenience sampling is the sampling where we choose our sampling units as per our convenience, right? If I want to test the IQ of particular age group in the students, and I don't want to consider the whole population. For example, I want to conduct the particular experiment in my university only, but I don't want to go to the whole university. And I just went out of my office and I found one individual, I took the test and I measured the IQ. That is my convenience because I don't want to do the labor. So in that way, we are choosing convenience over selection of the units. That is your convenience sampling. It is useful in the exploratory research design because in the exploratory analysis, it is not very important that you focus to each and every individual of that particular university when we are talking about. Okay. And also exploratory research design says that the study is more exploratory in nature. That means we are exploring the particular phenomena. Right, we don't have previous, we are not judging or we are not expecting some kind of result in advance. We are exploring. So in that way, convenience sampling is okay. Then we have judgmental sampling. So judgmental sampling is also known as purposive sampling because it is based on the judgment of the particular researcher. Right. So if we want to test, uh, if we want to test so if we want to test some kind of phenomena that is in the nature as, let's see, again, the IQ of a certain age group of the person, individuals, right? And so what we'll do is we are going to particular section of the society, right? And in that way, what happens is we are not going to the rural or urban or semi-urban area, right? So our purpose is to just measure the IQ of a certain age group. Yeah. And in that sense, we can just go to a particular section of the society and we can take the data, right? Our purpose is solved, right? But at the same time, there might be personal bias because we are only taken one section of the society and the IQ may be high or low in that particular society, or we are only considering one particular caste or crude that might show some unachieved level of IQ or education, right? So purposive sampling is a good sampling, but the person or the researcher should be bias free, unbiased person, right? And obviously, if a person is unbiased, then to fulfill their purpose, what will they do is, if I am going to test the IQ, I will go to the urban households also in a particular society, or for example, not take the urban society, urban or rural area either. Let's say, okay, we have a society in which we have low income groups, higher income groups, and middle income groups, right? And we want to check the IQ. Okay, so my purpose is defined that I want to check the IQ, but I'm going to each and every section of the group. Now here we are not using any kind of probability sampling, but we are trying to cover more all kind of variation that might be possible in particular society. Okay. Then we have quota sampling. Quota sampling is also very popular. In quota sampling, we fix certain quotas on the basis of appropriate criteria. Okay. So, quota sampling matlab, we are going to prefer some section, right? So, again, when we are talking about different sections of the society, we know that, for example, some part of the section, some part of the, some section of that particular population has to be given more importance, okay, over another part, over another section of the population. So we will take more units from that particular section of the population, right? So we are giving some kind of weightage to that particular section. So we are fixing quotas. Quotas हो गया different sections of the society. So different sections of the society will have different quota. Okay, and then we take the sampling. Now, in this case, the allocation of the subsample, we are taking the bigger sample and quota sampling, and then the individual, how the individual should be allocated is based on the proportional allocation or optimum. So, proportional allocation, when we were talking about the PPS, that kind of proportional, which have bigger proportional, we can use, right? But there is no technicality you can use in that way. Or optimum allocation means in which we can get, there might be cases where we have different quotas where the population might not be responsive, right? So in that case, if our purpose is to get the maximum response, then we will take uh, that particular units which gives you a better response. Okay, or the cost or time can be one factor for optimum allocation, right? Then there is one shopping mall intercept sampling, that is again a non-random sampling. And in that, that is again very popular. I think a lot of commercial places do such kind of sampling. Okay, so in shopping mall intercept sampling is we take the random people in the malls and we get the questionnaire done. You all might have experienced this because whenever we go to the shops, right, and they get the feedbacks filled from you, that is one kind of sampling again. Or some people fill and some don't fill, right? So we are taking feedback, that is questionnaire, and you are taking information on that basis. Different socio-economic information, location can be factor, right? Experimental research is the area where it is used, because we are not giving any kind of probability, we are not assigning any kind of probability to any area in any particular population. Okay, but our objective is again defined, because if we are focusing in the malls or marketplaces or socio-economic locations, we are catering or we are taking one sections of the society. Okay, that again depends on the researcher how they take the decision of going to the locations. Then we have controlled panel sampling. Okay, so control panel sampling is very effective. In India, it was in Bangalore, but uh, initiated in Bangalore, but actually it was initiated in Ohio. Okay, and it is generalized, no, not generalized, very peculiar form of quota sampling. So in quota sampling, we used to make quotas, and in controlled panel sampling, what we will do is we make panel. Okay, so it needs more of technical advancement, because in this process we have the information of entire population, right? Different kind of information, whether it is listing or individuals, or sorry, education or income groups, various income groups, and we already have the information of that. And then we make panels. Like in quota, we made quotas, then we make panels. For example, we can make panels based on age, we can make panels based on caste or religion, we can make panels based on different standard of living or income groups, right? So in that way, we will have different groups, and in that we take the detailed information, detailed survey. And those surveys can be done online or via telephone. This is very much being used in Europe, I have seen, because they are collecting the data in various demographic sections via telephone. Or we can say in the times of COVID, it was very much applicable, because we had the information of all the individuals and we were taking information like if you all remember, if you are being infected, then the data was being taken each and every day via telephone. Yeah? And at the same time, when you were being infected, when you were infected by COVID, the government was taking the all the information, right? So right after you get infected, you have your data in their system. So they have all the data of COVID affected people, right? And now they will conduct the detailed survey every day, like if you're getting fever or your oxygen level and all that. So this is one example of control panel sampling. But again, this is useful for rare population. Now, COVID was the one incident, rare population in the sense with the population where all the listing and all the data is already available. Otherwise, it will not be appropriate, because if the data is not available, then the whole survey can become biased. Then we have snowball sampling. Snowball sampling is very much effective when we don't have information about our sampling units. For example, when we talk about non-communicable diseases, HIV, for example. So HIV is one kind of disease that people don't talk about or they don't want to disclose, right? So, but what happens is we know that there might be more chances that one HIV infected person knows another HIV infected person, right? So what we do is we choose the initial respondent at once. We know that is section में or in particular hospital or there are particular HIV patients. Okay, and then in that after that what we do is we take the information from one patient and then we ask that particular patient if they know some other patient who are HIV infected or not. Then he or she will tell the name or sorry the other respondent, right? Uh, Probably two or three people. Then we'll go to those particular two or three people. So we are trying to build a network kind of thing, right? So we go to that particular individual, we take the information, we take the name of the people uh, or the possibility that other people will respond, and then we go to collect information from other people. So in that way, snowball sampling is done. It is very much effective because a lot of cases, lot of non-communicable diseases and mental health issues, and sometimes you can say different income age people, because a lot of people don't disclose their income, and drugs studies, intake of drug, inducing drugs. All of these studies are something that require a networking system, because we don't know the extent of our population. We don't have any information about population, right? So in that case, our, our snowball sampling might be very useful. So these are all kind of sampling procedures that can be used for sampling. Now it depends on your study how you are using your sampling frame. Most of the qualitative studies can be done by non-random sampling. Most of the qualitative studies, okay, or when we have quantitative studies, when quantitative studies say, I mean that we are taking measurements, different kind of measurements, IQ, BMI, heights, right, income, that are simpler. And in that way, we can get information from probability sampling, right? Ratings and all, they all go for non-random sampling. That is a better option. Now the determination of sampling size. A lot of people have a lot of confusion about how to calculate a sampling size, right? But it is very simple. You just have to know certain aspects of your population. So if you know a few criteria, then you can easily calculate the sampling size. Most of the studies, what happens is, I have seen in commerce and management, they take a very small sample, right? They take the sample of 50 or 100. Now what happens is, at in that particular situation, it happens that sometimes the results are not coming out to be good. Now the sample survey is already conducted, the observations are already taken. Now we cannot go back to the field again and take the sample. So it is important to know how much of the observations are actually required. For example, if I'm taking the 400 households for some phenomena which actually does not require that much of units, right? And 400 households means um, 1600 individuals if average size is even 4, right? And if we take the information on each and every individual, that will cost you both money and time. So it is easier if we decide how much our sample size should be in advance, so that our study can be more reproductive. We can use the resources somewhere else also. So sample size is basically the size of the sample, or is the number of individuals on which the data has to be collected. For that, we should know few criteria. That is our population size. If you know this one population size, then your study becomes easier. Population size means the number of people that are supposed to be included in your study, not the whole geographical area, right? For example, if we want to understand or we want to know the average height of individual in each age group, right? In age group of 10 to 21 years in a certain population, then the size of the population will be all the individuals, whether they are girl, boy, third gender, whatever. So all the individuals in the age group of 10 to 21. So you don't have to take the age group, all the people from starting from age 0 to age 85, right? You have to know the people in number of individual in 10 to 21 only. Okay. Then one important term is confidence interval. Now level of confidence, or confidence level, we call it. So confidence level is something which is very important to know, because a lot of calculations and even in the testing of hypothesis, it is important, because if we know how much confidence level we require, then the study can be effective, right? If there is medical study, then the confidence interval should be more, and if it is some different study, the confidence interval can be less. So the level of confidence, or the confidence level, is the level at which you are ascertain the accuracy of your data, right? So the data that you are collecting, that should be accurate enough. So for example, if you are taking 99% confidence level, that means you are 99% sure that your data is accurate. Again, which means that only 1% of the data is there of which you are not certain about. And that 1% data might be incorrect because of various sampling and non-sampling errors, right? So 99% accuracy is something which is not very much possible in practical situations. So there are fewer studies that take 99% of accuracy. Okay. Usually what we take is, we consider 95% or 90%. And that is also very good, because in 95% also we are taking that only 5% of your data might have some kind of error. Okay. And that error can be anything, whether it is chance or not by chance, right? Assignable, non-assignable, it can be anything. So mostly we take 95% only, and then we continue our calculation based on that. 99% level of confidence is required in a lot of medical studies, because when we are testing the drug, right, effectiveness of a drug. So in that case, what happens is, uh, it should be 99 because we are testing the drug on a human or an animal, right? So if the results are not accurate enough, then it can be more fatal in nature. If the drug is not tested properly and it goes into the market, then it will be more hazardous. So in lot of medical studies, the confidence level is taken to be 99%. Then there is the margin of error. इसको confidence interval कहा जाता है. Level of confidence is different and confidence interval is different. So marginal error is actually when we are talking about error. So you'll have to know that in what aspect you are taking your error, right? So when we were talking about average height, so the term that we are using is average. Okay. So average is, in statistical term, what else it is? Mean. Okay. So mean is something that is giving you the idea of your entire population, right? So when we are measuring entire population on the basis of one particular value, then it is your parameter. I'm sure you would have heard the term parameter. Okay. So in different cases, we might have mean, we might have variance or standard deviation or proportion. Okay. But mostly it is mean or standard deviation. Okay. So when we are talking about the parameter, we want our sample to be accurate. We want our sample to be more representative, right, in nature. And when the sample will be more representative, the value or the phenomena that we want to study will have more uh, accurate value. So if we are talking about average height, and say we are taking a sample, so average height of that particular sample, if the sample is more representative, then average height of the sample will be equal to or closest to the average height in the population, right? So that means the margin of error is very much less. So it is very important that our study should be such that there would be lesser and lesser margin of error as possible. So confidence interval tells you that the difference between the population parameter and the sample parameter. is how much? Okay, the lesser it is, the lesser good it is. So confidence interval might be big, right? So it is mostly plus minus the mean value. So for example, average height is say 10. Oh, sorry, I'm saying 10. Um, say 6 feet, right? Of population. Hmm. So, and we are saying that our confidence interval is plus minus 2. So that means the error is minimum in such a way that our sample value will either be 8 or 6 feet, we said, no. So, sorry, 4 this side, minus 2 and plus 8 at that side. So our sample mean will fluctuate between minus, 4 to 8 if the average value is that much. Okay, clear? So we take the difference of the population parameter and the sample parameter. Then it is standard deviation. So standard deviation, we all know variance. Variance is a very commonly used term, and variance tells you how much your population is spreaded. Again, spreaded from what? From the mean value. Okay, so it tells you the spreadness or the dispersion of data from its mean or average value. So mean is normally called as the measure of central tendency. Yani ke mean is something that represents your whole data. Okay, so if mean is something and then your variation is something, then plus minus those variation will be your area of dispersion. So the higher the dispersion, the standard deviation will also be higher, okay, and the population will be more dispersed. So even if your population or your sample, they will all be more dispersed, right? So you need to understand standard deviation. First of all, your population size should be clear, okay? Then your confidence interval, level of confidence should be clear, how much level of confidence you are taking. Then your margin of error should be clear, and your standard deviation should be clear. Standard deviation is nothing but the root of the variance, okay? So this is your standard sample formula for calculating sample size, right? N is equals to Z square sigma square by divided by the margin of error, where N is the required sample size. Now Z square is the term, Z square is the value of the standard normal variate. Standard normal distribution is something we are restricted by time also, so we cannot go through the whole standard normal distribution. But all you have to do is, you know your level of confidence, you check your Z score or Z value at that particular level of confidence that is already mentioned here, right? And if you have that, you put the value at in the formula, right? Then you have sigma. Sigma is the estimated standard deviation that you are expecting. So if you are saying 0.4 or 0.6, then there would be standard deviation or variance should be, standard deviation should be what? 0.4 or 0.6, right? So your value should be fluctuating in the confidence interval of plus minus 0.4. Okay. So these are the values. Margin of error, if you are fixing, margin of error is means, okay, how much your value will be dispersing. So I have taken one example also to how to calculate your sample size. So for example, we have a study and in which the confidence interval is 90, right? Your expected standard deviation is 0.6. Standard deviation could be anything, but based on some prior knowledge, you can fix your standard deviation. Okay. Then we have margin of error, यानी कि confidence interval जब बात करेंगे, that is plus minus 4%. 4% that is again 0.04. Okay. So what you do is you calculate 90% on 90%, Z value was 1.645. Okay. So we are taking 1.645. Now the whole value comes out to be 603. Clear? So that means the total number of respondents that you are required to gather information upon is 603. Okay, so that depends on, the whole thing depends on the standard deviation in the margin of error and your level of confidence. And that all again depends on the size of the population, right? Another example, okay, so here we were talking about margin of errors. But in this kind of situation, we had no information about population mean and sample mean. We haven't used it, right? But for example, we want to test some kind of hypothesis, right? For example, if someone says that the average height is say 5.3 or 5.6, and you want to test it, right? So what you do is that population parameter is given as 5.6 and your sample mean is supposed to be hypothetically is supposed to be 5.3. So now we have the population value and we want to check whether your sample value is equal to your population value or not. If the sample value is not equal to the population value, then there might be two cases. Either your sample size is sample is wrong, or your information about the population is wrong, right? So in testing of hypothesis, what we do is we check whether your sample is belonging to your population or not. So in that case, we have information about both the sample mean and your population mean. So in that case, your marginal error becomes population mean minus sample means. That we were talking about, no? The whole concept, because the estimated value should be as close to your actual value as possible. So the same thing you can do for population mean and sample mean. See, I have taken, this is for you to do, determine the sample size of, if the confidence level is 99%. So what you will do is, you will take the Z score at 99%, that is 2.576, right? Then your population mean is already given, that is 5.6, and sample mean says 5, and standard deviation that you are allowed is 0.6. So you can simply calculate with the same formula, but your denominator will be changed. We have different kind of different formulas for calculating the sample size, but these two are the easiest and the most popular used formula. But when you go for multi-stage sampling or multi-phase sampling, you have, right? So in that time, you have to also take the size of the population or stratas or characteristic, all those characteristic in account, so that you can make a better decision. So at every stage, the sample size might differ. So PPS, in that matter, we use PPS more, PPS sampling, and we can simply take the uh, samples based on that. So first we divide first we decide the sampling procedure, what we are going to take, sampling design, and then we go for sample size. Now is your, we have what, 7-8 minutes, or sorry, 2 minutes. So वैसे तो I saw that in your curriculum you already have questionnaire design, but questionnaire is also one of the, obviously it is a very important part of sample surveys, because if you're not asking the right question, that means you're asking the wrong questions, and if you're asking the wrong question, then your whole study will be obviously a waste of money and resources, time. Okay, so a questionnaire, these are some of the properties that I have written for a questionnaire and that are very important. So whether you are doing any basic study or you are doing some big major study, your questionnaire should be formed in such a way that it gives more accurate results and it should be free of errors. Okay, so we have different kind of methodologies to check the accuracy of a questionnaire. We have reliability, test of reliabilities, we have test of validities, content validities, etc. From which, but apart from that, if you are framing your questionnaire in a more informed way, then obviously the chances of errors or any kind of error, whether it is sampling error, non-sampling error, will be reduced. And if it is reduced, then you'll get a better output. So the first point is your questionnaire can be both qualitative and quantitative in nature. Qualitative when we are taking non-measurable phenomena such as any kind of attributes can be there. So a lot of study includes, for example, your behavioral studies, right? Or your preferences. Those kind of studies uh, uh, have scales, right? So in various websites also or various apps you use, Zomato and Swiggy, etc., they have ratings, right? That is one of the type of questionnaire also. So they are taking the responses on the basis of a rating. So there your data is qualitative in nature because you're not measuring it. And at the same time, when you're taking quantitative, then that means your age, income, and area, land area that you have, right? That is all quantitative in nature. A question can, so the questionnaire can be both qualitative and quantitative, and at the same time, it can be inclusive of both the properties. It should be clear, objective should be clear. Obviously, we are, if we want to take the information of income or education, you're not going to talk about something else. So it should be clear and it should be straightforward. Okay. Then we have questionnaire must be divided into various sections. So nowadays what happens is we take a elaborated study we conduct. So in that case, all kind of information is necessary. So even if we are studying some kind of factors that might be affecting some another factor, general information is always required. For example, the name, which is normally not disclosed, so we assign some kind of unit, okay? So the name is there, and then the age, and then we have sex, then we have date of birth, right? These are general information. Where we have caste, right? And we have monthly income. These are general. Socio-economic information are mostly, these are general information, the level of education, etc. So this can be put in one section, right? Section A. Then we have topic related question. If we want to study mental health or disease prevalence, then the question related to that will be that in that particular section. For example, if you want to study the status of women, right? So in that matter, what you will do is you will put the uh, questions related to empowerment or status of a woman in a household. So the questions will be such that they show the status of women in a household. So there are different kind of questions like who takes the decision and who's more socialized or do they have freedom to go out of the house, right? These kind of questions. But you put it into a different section. Then we have views or perceptions. Malia, what do you think about dowry, right? That will be different. Do you take dowry? That will be different, right? So it can be put in another one. And if at the same time you have ratings or preferences, then you put it into different sections. So putting, bifurcating, dividing your questionnaire into different sections makes it easier for the interviewer and the respondent both, because it is easier to switch from one to another. If it is intermingled, the respondent might get confused in responding, right? And at the same time, your interviewer might not be that good to convey the distinctiveness of your questions. Number should be kept adequate. It should not be too small or too large. It should be dependent or it should be very particular to your objective, right? In some questionnaire, you would have seen that they take the data. For example, you want to know the age, socioeconomic variable I'm talking about. So you want to know the age also. So for age, what you do is there is date of birth and age. So when you are asking about date of birth, you shouldn't ask about the age. Or when you're talking about age, so you just ask the age, you don't talk about the date of birth, right? So you're putting two questions in place of one. At the same time, when you're asking about the monthly income, so when you're talking about monthly income, it might happen that you ask the direct question, how much is your income? You're putting that. And at the same time, you have another question, which has these categories that lower income, higher income, middle income, and so on. And then you're putting that also. So you're increasing the number of questions. So it should not be too much, right? It should be very much limited. Question should be arranged logically. That means it should be stepwise. First, we are taking general information. Then we are taking the information regarding the topic. Then we are taking information that are based on the views or the thinking or the thought process, right? So it should be made that way. Okay. So in that way, again, it becomes easier for both the researcher, the interviewer, and the respondent to understand the questionnaire and respond properly. Okay. Then the question should be direct. That is obviously, that is a very obvious thing. The question should be very clear. If the questions are clear, then it becomes easier for the person to respond, even if they want to respond or not. Okay. Then personal questions should be avoided, right? Personal questions, because there are different studies that can be used for that. But usually when you are studying the general topics, the personal questions should be avoided because the people might not get very much comfortable with that. Okay. Instructions must be there if required. Instructions must be there for both the people, both the persons, for the interviewers and your respondent. Because normally the person who is designing the questionnaire is not going to collect the information, right? So the person who is going is different. So there must be your instructions there. Question should be objective or multiple choice. ये preference it should be there. ये preference होना चाहिए that वो objective है या different classes में divided है. Open-ended question should be given preference. For example, age. Now we were talking about age, so date of birth. Considering date of birth is a better option, right? But at the same time, if you are considering the older population, now in older population, what happens is they don't remember the age a lot of times. Date of birth, sorry, right? In that case, asking the age is important, so it should be clear. Income, in income, you should not make the categories in advance. You should take the direct value, whether it is 5,000 or 1,500 or 5,050 rupees, right? And then later on, when you're doing the data entry, you can divide it into class. It becomes easier to analyze, right? Because you are not cutting off the data. Preference of certain clothing brand and all, that should be kept open because you might not know all kinds of brands that are there. Maybe there are different brands in that particular area, right? These kind of questions. Uh, these two below two are the important things. Questionnaire purpose must be stated at the top of the questionnaire. So when you are designing your questionnaire, you give your title, no? So the purpose is also should be there. Like if you are using it for the research purpose or not, it should be mentioned there. So in every questionnaire, there should be a clause written that the particular information will only be used for research purposes. In that way, the confidentiality is also maintained. Okay. Confidentiality of the information should be maintained and should be clearly stated, should be there. Pre-testing, very important. We do pilot studies. In pilot studies, we don't directly go for conducting the whole sample survey. What we do is if we want to collect the sample survey of 500 households, first we go for 50 households. And then we see the responses. Now, what will happen is you will get to understand the problems that are occurring in your sample survey. There might be non-responses, or there might be questions that are proving to be ambiguous to the respondents. So now, after getting the 50 questionnaires done, you can change the questions and go again. That is called as pre-testing or pilot surveys. That is very much smaller in size than actual survey. And then it is very important that for the topics that are very sensitive or that require separate kind of knowledge, in that cases there should be uh, consultancy taken from the experts, right? So, for example, if you are doing mental health studies or non-communicable or domestic violence, sexual harassment, these all are the studies in which you cannot ask the respondents direct questions. They might hurt their sentiments. So, in that situation, if you ask ask various kind of experts, you can consult the NGOs, you can consult the doctors, psychiatrists, or if you are going for the study in the stock market, you can go talk to the particular person who can give you a better suggestion that such questions should be asked and such questions should not be asked, right? So consultancy should be done, and it should be very important part of your questionnaire designing. Okay, so these are some of the properties that should be followed in your questionnaire designing. Then we come back to the collection of the data. Now, collection of the data, we have already talked about different kind of sampling errors and non-sampling errors that can occur during collection of the data, right? So, keeping that in mind, you can go for your uh, uh, data collection, and you can do the data entry and all. So, there is no sense of sharing the screen again. That is your end of the presentation as well as the lecture. Thank you all for your patience. And if there is any kind of question, you are most welcome to ask, please. Thank you.